Good afternoon, students. So today I take the topic of homogeneous linear partial differential equation with constant coefficients. So in this class I show what is a homogeneous linear partial differential equation and how to solve those partial differential equations. So here you have some rules to find its complementary function and also to find particular integral. If you are perfect with these rules, then it is very easy to solve such homogeneous linear partial differential equation with constant coefficients. So now let us see what is a homogeneous partial differential equation. Okay, so an equation in which partial derivatives occurring are all same order means a partial differential equation in which all partial derivatives are having degree 1 and all the coefficients are constant, then those equations are called as homogeneous linear partial differential equation with constant coefficients. Now in this case, this is a homogeneous partial differential equation. This is a homogeneous partial differential equation. Okay, in this case, so this one, homogeneous partial differential equation. Now here all the partial derivatives exist in first degree, but order is different. Okay, so order is different. So here this first partial derivative has order is nth order partial derivative. Okay, but degree is 1, and similarly here this second is, it's a partial derivative of order, it's also of order n, but degree is again 1. Okay, so like that all the partial derivatives are of degree 1. Okay, so this is one partial differential equation which is equal to what? F of xy. Now here, to find its solution, we assume that let d is equal to dou by dou x and d dash is equal to dou by dou y. So here, okay, d is equal to dou by dou x and d dash is equal to dou by dou y, we assume. Then nth order linear homogeneous equation is given by, now substitute all these, d is equal to dou by dou x as d and dou by dou y as d dash in this equation, and it takes the form of this one. Okay, in this equation substitute all d as dou by dou x and d dash as dou by dou y. That means the first derivative is d raised to n. Okay, d raised to n. Okay, like that. Now here this is what? Dou n by dou x raised to n, so which is d raised to n minus 1, and dou by dou y is d dash. So like that you replace all the derivatives and we get this equation. This is a simplified homogeneous linear equation. Okay, and this differential equation is represented by simple, that is f of d comma d dash, because it is a function of d and d dash. So we write this whole equation instead of writing such a lengthy equation. We write it and we make it as short, and we denote this by f of d comma d dash, then z, which is to be operated on z, is equal to f of xy. So both this equation and this equation are one and same. Okay, so next is equal to d dash. Okay, next we now the complete solution of this consists of two parts. So one is the complementary function and the particular integral. The complementary function is the complete solution of the f of d dash z is equal to 0. Now we have to find the complementary function. Okay, now we see the rules to find complementary function. So what we do, we consider a second order linear PDE. Okay, we consider a second order linear PDE of this form: dou square z by dou x square plus k1 dou square z by dou x dou y plus k2 dou square z by dou y square equal to 0. This is a second order linear partial differential equation with constant coefficient. So here k1 and k2 are constant. Now as I earlier told, replace d by dou x as capital D. So this becomes d square plus k1. Then this is d. Then dou by dou y is d dash. Then plus k2. Dou by dou y as d dash whole square. Dou square z by dou y square, it is d dash whole square. Then take z common, so which is to be operated on z, which is equal to 0. Now this is equation 2. Okay, now after finding this one, next what we do, we find the auxiliary equation. So in this case, to find auxiliary equation, what we do, we put d is equal to m and d dash is equal to 1. Okay, d is equal to m and d dash is equal to here in this equation, put d is equal to m and d dash is equal to 1. Then this equation becomes m square plus k1 m plus k2 equal to 0. This is equation 3. Now solve this equation. M square plus k1m plus k2, it's a quadratic equation. Then solve this equation and you will get two roots. Okay, so m1 and m2. Now depending on the two roots, we write the solution. Okay, we have a formula for the complementary function. So if m1 and m2, case 1, m1 and m2 are two distinct roots and real. If m1 and m2 are two distinct roots and are real, then the complementary function, our complete solution is given by the equation z is equal to f1 of y plus m1x plus f2 of y plus m2x. So this is the complete solution when m1 and m2 are two distinct and real roots. Okay, so this is case 1. Next, case 2. If the equation 3 has two equal roots, say if two roots are equal, m1, so suppose that two roots you are getting m1 and m2. If both the two roots are equal, m1 is equal to m2, then we write the complete solution as z is equal to f1 of y plus m1x plus x into f2 of y plus m1x. Okay, so this is the rule when the two roots are equal. Okay, next we find rules to find the particular integral. So to find the particular integral, we write the given equation as d square plus k1 d dash plus k2 d dash whole square z is equal to f of xy. Now this can be written as f of d comma d dash z is equal to f of xy. Okay. Next, therefore, particular integral is what? 1 divided by f of d dash f of xy. Now in this case, case 1, if f of xy is equal to e raised to ax plus by, in that case the particular integral is given by 1 divided by f of d dash, which is to be operated on e raised to ax plus by. So which is equal to, in this case, to find the particular integral, replace d by a and d dash by b, right? Here x coefficient is a and here y coefficient is b. So replace d by x coefficient, that is a, and d dash by y coefficient, that is b. So which is equal to 1 by f of ab e raised to ax plus by. And here one more condition is that f of ab should not be equal to 0. F of ab should not be equal to 0. Okay, so now if suppose, what happens, sometimes you will get f of ab is equal to 0. So in that case, d minus a by b d dash is a factor of this equation, and therefore we write the particular integral as we write the particular integral as pi is equal to x into e raised to ax plus by. So this is the particular integral when f of d comma d dash or f of ab is equal to 0, then x its particular integral is x into e raised to ax plus by. Okay, now suppose in sometimes second time also you may get f of ab is equal to 0. In second time also you may get f of ab is equal to 0. In the second time, if you get f of ab is equal to 0, then the particular integral is given by x square by 2 e raised to ax plus by. Okay, so this is the particular integral. Next, case 2. If f of xy is equal to sine of mx plus ny or cos of mx plus ny. If f of xy is sine of mx plus ny or cos of mx plus ny. In that case, the particular integral is given by pi is equal to 1 divided by f of d square comma d dash comma d dash square sine of mx plus ny. So in this case, write sine of mx plus ny as it is divided by, here you replace d square by minus m square and d dash square by minus n square and d dash by minus mn. Okay, here so d square is replaced by minus m square, d dash is replaced by minus mn and d dash square is replaced by minus n square, which is the particular integral when f of xy is sine of mx plus ny or cos of mx plus ny. Okay, next case 3, when f of xy is equal to x raised to m y raised to n. Okay, case 3, when f of xy is x raised to m y raised to n. In that case, particular integral is given by 1 divided by f of d comma d dash x raised to m y raised to n, which is equal to, now this bring this f of d comma d dash in the numerator, which gives f of d dash raised to minus 1 x raised to m y raised to n. Now expand this f of d dash raised to minus 1 in ascending powers of d by d dash and operate it on x raised to m and y raised to n, so which gives the required particular integral. Okay, so now case 4, when f of xy is any function of x or y. Okay, when f of xy is any function, so either it may be an exponential function or it may be a trigonometric function or it may be a logarithmic function, okay, or it may be a tan function. So in that case, this particular integral is given by 1 divided by d minus m d dash of f of xy, which is same as integration of f of x comma c minus mx dx. Okay, so this you will understand while solving the problem. Okay, this you are going to understand while solving the problems. Okay, so these are the 4 type of rules to find the particular integral, and also there are some 2 rules are there to find the complementary functions. So using these rules, in the next class we solve the problems on homogeneous linear partial differential equation with constant coefficient. I hope you understood the today's concept, and I'll continue in the next class. Thank you.